Yeah, okay. So does that answer what your question was, or did you have, or does that just muddy it up?
No, yeah, that's all right. That makes sense.
Okay.
So you can do it two ways.
Yeah, a rational exponent, yeah. And aside of that, when we had like 16 to the 1/2 power, okay, that was technically the square root of 16 to the 1 power, but that's just a waste of time. The 1 wasn't necessary. So we just say the 1/2 power is the same as the square root of 16, which is.
Here's what I found.
Oh, God dang it, wait a minute. So now I have to turn my watch off? Everything's turned off. Okay, so we did this quite a bit, or 27 to the 1/3 power becomes the cube root of 27 to the 1 power, which is just the cube root of 27, which is just 3.
Okay.
Okay.
Yeah. Okay. I'm writing the. I'm writing all, like everything down.
Okay. I'll wait till the stuff.
Yeah.
No problem.
Can you show me what the expressions are?
Sure. Then a rational expression, again, the root word is rational, means fraction. So we had something like that would be an example of a rational expression. Okay, and then we did all kinds of stuff with it. Okay, so for example, we reduced it. Okay, if you're asked to simplify or reduce, that means factor. So we would take a 2 out of the top, factor a common 2 out of the numerator, and factor the denominator would be a dose. And then whatever cancels, cancels. And so we would get the reduced or the simplified answer would be 2 over x minus 3. And I talked about having invisible parentheses around it.
Oh, okay. Yeah, I remember these.
Remember those?
Yeah.
Then off of that, are you ready to go on?
Yeah.
Okay. Off of that, we also talked about restrictions. And because this is a fraction, okay, very important, because this is a fraction, this has a restriction that says the denominator can never equal 0. Okay. Let's erase. I just made it worse. Shoot. Okay, so if we had something like 5x plus 7 over 3x minus 2. Okay, then we would say, oh, to find the restrictions for this, this would imply 3x minus 2 cannot equal 0, because that's the denominator.
Yeah.
And then you solve that, add 2 to both sides. Okay, divide. And we say that's not the solution, it's the restriction. Because that says x can't be 2/3, because if it was, it would make this denominator 0 and the world would end.
Oh, okay. Yeah, I never knew how to find those. I mean, I forgot how to find the
Well,
restrict like that. Sometimes
Yeah,
it
I
just
mean,
makes sense.
it's just pretending it's an equal sign and solving it. It's just saying, but you're saying it can't be. For example, what if we had 3x minus 9 over, well, let's take this x squared minus, no, I don't want 3x minus 9. I want 3x plus 5. Okay, that's better. Okay, so on this one, we say our denominator, x squared minus 9, cannot equal 0. And now you say, well, okay, how do I solve that? Well, because it's a power equation, we can factor it. X minus 3, x plus 3 cannot equal 0. And then we split it up and we say x minus 3 can't equal 0, or x plus 3 cannot equal 0. And we get two answers, but basically it's x cannot equal plus or minus 3. So we get two answers out of that one.
So I did it at the same time, and I just did x equals square root of 3. If I would have done that, then that's wrong, right? Because I have to actually.
Well, okay, this problem here has two ways to solve it. Okay, I chose the factor method.
Okay.
Okay, if you had the same problem and you made it x squared cannot equal 9 because you added 9 to both sides.
Yeah.
Then we took the square root of both sides. And this is where you have to remember the plus or minus. You have to cheat it in. The shortcut says, if you're going to use this, you have to remember that when you take the square root of both sides of an equation, you have to be sure to insert a plus or minus. So the square root of 9 is 3, and we get the same answer. So yes, it would be partially wrong if you only had the 3. You have to have both of them, because again, remember, anything with a power of 2, any equation with a power of 2 usually has two answers. So then off of rational expressions, we talked about adding with a common denominator or not a common denominator. We talked about multiplying, dividing. We talked about equations and all kinds of stuff. And it gets, I don't have examples of those, but those are all in your exam number 2. So if you could find an example, I could redo it for you.
Okay. Well,
Or if you think you remember, it's okay. I mean, we don't have to do it.
yeah, that's not too hard. I mean, I sort of got scared a little bit with the fractions. I mean, the exponents, sorry. But
Okay.
I mean, it makes sense. You just gotta
Make
have
sure you practice it. Make sure you go over your exam number 2 and can do those, because the answer, remember, is the answers are online. I mean, I put them all up there so you could redo it and then check your answers.
Yeah. Yeah, I'm gonna do that because I kind of forgot all of that. So
Right, and I know. Go
it's
on
been a
here.
I'm still the only one on here. Okay. Well, could you maybe just go over the rest of what we're gonna do in the first part of the exam?
Well, like what? I mean, I don't know. There's a whole lot. We're gonna add, subtract, multiply, divide. We're
Well,
gonna,
after that, well after that part, it's from exam number 2, chapter 8, intermediate roots and radicals. So adding, subtracting, multiplying, dividing, rationalize.
well, that would be like, can you simplify the cube root of 54, x to the 5th, y to the 7th? Can you multiply 2 square root of 3 times, I don't know, 5 square root of 6? That's multiply. Can you add the square root of 8 plus the square root of 27 plus the square root of 12? Do you want to try those? I mean, I just made those up. I have no idea.
Yeah, I'm gonna go ahead and do those. I'm pretty sure I can do
Okay. So let's pause. I'll pause the video while you work on them and then let me know.
Sounds
So let's see if I can do this. So I see this as the cube root of 2 times 27 times x to the 3rd times x to the 2nd times y to the 3rd times y to the 3rd times y. Okay. So skipping a step, I know, because I've been doing this forever, that the cube root of 27 is automatically 3. Is that okay? So I'm going to take out a 3, and I'm going to take out an x because of this, and I'm going to take out 2 y's. And what I'm going to leave inside is a 2, an x squared, and a y. Put it all together, I have 3x y squared times the cube root of 2x squared y. So that would be my answer for the first one.
Yeah, that's what I got.
Good. All right. When we do the second one, who joined us here? Ted. Okay. By the way, Ted, I have to apologize. I turned off the game the other night and you said, is that the final score? And I thought for sure it is. And I had no idea that the Rams could lose or could come back and win that fast. But oh well, whatever. So anyway, on this one, when we're multiplying, we use the outside, inside rule. Okay, so we start with, this is 10 square root of 18. Okay, outside, 2 times 5 is 10, inside. But we have to simplify always what's inside. Okay, always simplify. So this is 10. Okay, your calculator does square roots, remember that. Okay, I don't happen to have my calculator with me, so I have to do this as 9 times 2. 18 is 9 times 2, because I know that the square root of 9 is 3. So this is 10 times the 3, and the square root of 2 stays inside. So final answer is 30 square roots of 2. 30 times square root of 2. Is that okay?
Okay. Yeah.
Okay. Now we might have used different steps, but if you got down to the same answer, then we had to be using correct logic. So, all right. Now, on the surface, you can't add these. It's very, very important because the inside numbers are all the same, are all different, rather, excuse me. You can't add them. at all. You're stuck. Okay, so, on the surface, you say, I quit. But the other rule is you have to be able to simplify all radicals. So the square root of 8 becomes 2 times the square root of 2. The square root of 27 becomes 3 times the square root of 3, and the square root of 12 becomes 2 times the square root of 3. Now, I can show you how I did that or not. I mean, again, your calculator does square roots. So I would, it just does them for you automatically. So I would definitely use that. Now, however, now you can add these. Okay, those actually do add. So we have 2 square roots 2 plus when we add these, remember, if we had to add 3x plus 2x, what we actually do is add the 3 and the 2, we get 5x. Well, the same thing here. 3 radical 3s and 2 radical 3s make 5 radical 3s. And that would be our final answer there. Is that okay? Did you get all those?
No, I got the lesson wrong, so I'm writing it down.
Okay.
It was easy. It's pretty easy, but okay.
Do you understand? Well, where did you screw up?
I just added them, but I don't know. I probably got that idea from trying to multiply them because they're all
Right. Addition and multiplication, totally different ideas.
Yeah. So what I got is square root of 47, which doesn't.
Yeah, no, you can't do that. You had to simplify each one separately.
Yeah, that's me. Welcome. I got it.
Okay. And then okay. Ted, do you have any questions about the ones that are up here? I've got about 2 more examples I'm going to do.
Yeah, I was going to, it was a quick question. You know how you use the logarithm or the ln, the natural
Yeah.
logarithm? Can we use those interchangeably, or do you want like
Yes.
you can? Okay, so
Yes.
okay, I was just making sure because I seen how you used ln and log, but it wasn't specific. Only with the e you used ln, or you can use log with e as well, right?
Yeah, the advantage of using ln. Okay, first off, the whole big topic is called logs. Okay, and then there's log base 10. Okay, there's log base e. There's log base 2 if you want. Okay, and so when we say logs, okay, we mean any of these that you want. And the log base e is the ln of somebody, okay, of whatever. And that's easier when you have an e in the problem.
Got it. Okay, I see.
Okay, but all of these are called logarithms.
So you can use them all interchangeably. Okay.
Yeah, so the log laws work for all of them. You just pick the one that's easiest for your particular problem.
Got it. Okay.
Okay.
Did you like that comeback, huh?
Yeah.
They came back in like 1 minute and 45 seconds.
I couldn't believe it. That's why I told you. I said, "Oh, game's over." Whatever. And I'm looking at it, going, "Holy crud! What happened?"
Yeah, that was pretty cool.
Yeah. All right. Back to Jorge. Here, the other one. Do you remember how? Let's say we had 7 over the square root of 6. Do you remember how to simplify that?
Let's see.
And also, what about 5 over the cube root of 2a? And one more. what about 3 over 2 plus the square root of 5?
Are you asking us all, both, or are you just asking Jorge?
Well, he was asking me questions. It could be anybody. It doesn't matter. He had asked me a question before you popped in, so I was finishing off my ideas with him. I just squeezed you into the middle. I'll come back to you as soon as we do these.
Okay, I'll let him answer. I already know these.
Okay, that's good. I mean, yeah, but yeah, okay. So give me a few seconds, Jorge, and then let me know when you're ready. I turned on the record. Jorge, is it okay if I talk while you're working on these and then I come back to this?
Yeah, that's fine.
So let's make up a problem. Like you have the log of 15 plus x plus the log of 7 minus x equals 11. I have no idea what this problem is. I don't know what the real answer is. But let's say we work it out and we get an answer of x equals 5 or x equals -2. This is all pretend now.
Okay,
Okay, so we get some big ugly log problem. Okay, and we work it all out, and these are the answers we get. Well, what matters is if I plug 5 here or here, is the inside quantity positive? So if I take 5 and plug it here or here,
yeah, they both are.
then 5 is okay.
Ah,
If I take -2 and plug it here or here, is the inside quantity positive?
yeah, they both, yeah.
Then -2 is okay.
Oh,
It's
that's all you have to,
only-
that's all you have to
Yeah.
tap is inside, oh,
That's
okay,
all you have to,
inside the
yeah.
parentheses.
yeah,
Oh, okay, got it.
okay. The fancy vocabulary is the inside the parentheses is called the argument of the function.
Okay,
Okay, so that quantity must be positive always.
okay, gotcha. Because I don't know how I was doing it.
Yeah. Okay, X might be negative, but when you plug it in, does it make the quantity positive? That's
Right,
all
okay,
that matters.
okay. So in order to solve that, we would have to do log 10, because we're assuming it's 10, right? Log 10
Yeah,
times 15 plus x times 7 minus x
yeah,
Okay.
equals 11.
equals, okay, I was just making sure that's how you do it. Okay.
Yeah,
So we're,
and then use the blah rule to change it
got
exponential.
it. Gotcha. And it's condensing, right? Okay, gotcha.
Right, condensing, yes.
Okay.
Okay. Jorge, how you doing?
Well, I already got my answers for those. I was just wondering about that one. Could you find does the same logic apply as what we were doing earlier on the other problem? That you find I mean, are we gonna have to find what are they called? I wrote it down. Sorry, never mind. Let's go back to these.
Back to these, okay, we can go into logs again, that would be a good one to do. Or remember, if we didn't cover a lot tonight, we still have tomorrow night also, so don't panic, okay? All right, so back to this one. The overall rule is for a final answer, you can't have a radical in the denominator. So the typical way we do it is we multiply top and bottom by the square root of 6. Okay?
Yeah.
So that gives us 7 square root of 6 over the square root of 6 squared, but the square root and the square power cancel out. And that's our answer.
Yeah,
Okay?
that's what I got.
Now, the problem is if people learned this in high school, they usually learned a really bad habit. They just thought we could automatically multiply by whatever's in the radical, and that's not true. Like this problem, you can't just automatically, this is wrong, so don't write this down, I'm gonna erase it. You can't just automatically multiply top and bottom by the cube root of 2a. That won't do anything. Okay? Is that thing out of focus or is it just my eyes? Can you, you guys can
Just put the red.
Huh?
The red's really, the red's kind of
Bad?
the ink is bad. Yeah, it's not you.
Okay.
It's just the ink.
Oh, all right. It's not me. It sounds like a girl I used to date. Never mind.
You got her.
it's
You
not
knocked
you.
her up. You knocked her up.
No. Hey, no. Okay, so what you have to do is to get out of a cube root, you have to have cube powers. To get out of a cube root, you need cube powers. So to do that, does the orange show up?
Yeah.
No, that's even worse.
Yeah.
Does it?
Well, no, it's just like it's because it's light and it looks blurry.
Yeah.
That's the way it is.
I wonder if I have any.
You have
next
green or
color. I'm gonna, no, but I may
mean-
have blue. Huh?
You can still use them. I mean, I can still see it.
Okay. Never mind. Red, green. That's red. Come on. Hang on, give me 30 seconds and I'll see if I can. Black, no. Blue colors. Ah, let's see if this one works. Yeah, sorry. So, let's see if this works. So what you want to do is multiply by 2 squared a squared to top and bottom. Okay, and the question is why? Well, because on bottom we get 5 times the cube root of this mess, which is 4a squared. We don't care about the top. But on bottom, what we've created is inside the cube root, we have 2 to the 3rd power, a to the 3rd power. And those are the only things that can come out of a cube root. So you had to think ahead. I need 2 to the 3rd power. So I have 1 of them, I need 2 more. I need a to the 3rd power. I have 1 of them, I need 2 more. So that's what we did. So this becomes 5 times the cube root of 4a to the 2nd on top, whatever that is. And on bottom, both of these come out. So that would be our final answer. Is that okay or not okay?
Yeah, that's not what I got, but yeah, I remember.
Do you understand?
I remember now.
Okay. All right. Let me come back to this one and then I'll jump to Ted and I'll come back to you and see if we get different problems, okay, for you. So this is a binomial. Over here, the first one, this is a monomial. And if you think about it, how do we fix a monomial? By multiplying it by another monomial, by one thing. This is a monomial. So how do we fix a monomial? By multiplying it by another monomial. Mono meaning
Yeah.
one quantity. But this is a binomial. So
That
we
has to be the
fix,
conjugate, right?
by who?
The conjugate,
Yeah, which is what?
it's the same except with the minus.
Good. To top and bottom. I don't know. So this gives us on top, we have 6 minus 3 radical 5, because we distribute the 2 to everybody, and 3, I mean to everybody. Okay, but on bottom, we have to FOIL everybody together, so we have 4 minus 2 radical 5 plus 2 radical 5 minus radical 25. Because what we did 2 times 2, 2 times negative radical 5, radical 5 times 2, and radical 5 times radical 5, that's where we use the inside, outside rule to get that. Okay, so what happens here is the 2 radical 5s cancel out because one's positive, one's negative. So we get 6 minus 3 radical 5 on top. On bottom, we get 4 minus, that becomes a 5. So we get -1. So final answer, 6 minus 3 radical 5 over -1. Actually, that could be simplified a little bit more, but right now for tonight, I'm not going to worry about it. Does that help?
Yes.
Okay. All right, Ted, question.
No, I was just here to observe some of the questions. Those are the
Okay.
two questions I had, was just those 2 questions.
Oh, okay. Good. Okay, then other questions? It's only 2 of us. This is a great review.
Yep.
I'm hoping somebody shows up, but then again, I don't know. Is anybody watching off to the corner of the football game? I think it's.
Yeah. Oh, I just turned into it right now. I didn't check the score or anything. I was watching a Christmas Carol.
Humbug. Okay, so I don't want, Jorge, I don't want to belabor this because this will not be a big topic on the test. But what if I had 6, let's go the cube root of 3x squared y. This is a little bit tricky.
Okay. I think I got it.
What do you think you got? What'd you get?
Well, I have 6. In the index, I have 3.
Yeah.
inside the radical, I have a 3 squared x y squared. So it's,
Okay, 3 squared is 9, yeah. On bottom,
I have a 3xy.
okay, perfect with one minor exception. At the end, what about 6 and 3?
Oh yeah, I should have done 2 and 1. My bad.
Yeah. No, that's minor. You've got the basic idea. You got the good, big idea. But, so you did it right. Good job.
Cool. Thank you. I just
Okay.
need to practice.
Yeah, yeah. Okay, for both of you. Can you solve this? X squared minus 3x minus 10 is greater than or equal to 0. And I think I give you a hint on the test. I say you must use interval testing.
Okay. Can I just tell you out?
Yeah,
So you make it into an equal sign first,
yeah,
and then there will be x plus 3 plus 2 x minus 5,
yeah,
and then you put it on a number line,
yeah.
and then
And
you
go ahead and try those.
okay.
Go ahead and try that.
Okay.
No, I'm not recording the program.
Okay.
No.
Isn't it just 40?
I get 400. Did I enter it wrong? I used my calculator. I didn't even bother to do it. Oh, that was the problem. Okay. Boy, I entered 2,000 instead of 200 here.
Oh,
So my answers are totally wrong. Let me make sure everything is right.
well, I got You want me to tell you or you want to do it?
50. So go ahead, what'd you get?
I got a negative 0.2 and 40.2.
And T sub 2 equals, yeah, you're right, 40.2484. So the answer would be 40.2, probably seconds, but I didn't give that to you, so you're right. Did
Yeah.
you use the did you use your calculator?
Yeah, I just put it in there.
Good, okay. Now, this one, notice I only circled the second answer because the first answer doesn't make sense.
Yeah, can't have negative time.
Right, right. So even though your calculator gives you the two answers, you have to be smart enough to know, okay, the first one doesn't make sense. The second one is my answer. Okay.
Okay.
Have you finished part B?
Yeah, I got in 20 seconds, it's gonna reach what is that, 50,000 meters?
Is that right?
Feet.
Whatever. Okay, so the max height is the vertex,
Yeah,
which is negative b over 2a, so negative 200 over 2 times negative 5, comma, something, so that's, you said
20
20,
and
comma,
20.
now. So what's that? Negative 5 times 400 plus 4,000. Is that right? Plus 50?
Yeah,
I think I did that right. Let me get it different. So that's 2050. Is that what you got?
yeah, that's what I got.
Okay. So this is comma something. So final answer is 20 comma 2050. So max height is 2050, probably meters, whatever. So you didn't need, you didn't need to tell me what the 20 was. You just needed to use the 20 to get to the other stuff. Okay. Shoot, I don't know what else.
Well, I think I just have to memorize the circles, the lines. I mean, not the lines, the circles and the hyperbolas, all those type of like.
No, those aren't going to be on. Those aren't going to be on the test. If you look at that. Oh, no, I'm sorry. Yes, graph a circle. That will be on the test. Solve a system, just like the ones that were on the exam number 4, and parabolas.
Could we do one of those parabolas and find the vertex, the X, Y, and all those?
Sure. Okay. Can I erase this?
Yeah.
Okay, hang on. Oh, yeah.
And so we get this.
Vertex is negative 8 over 2 times 2. That's 8 over 4, which is negative 2, comma 16. What? Oh. Negative 13? Did I do that one
Yeah.
right?
Yeah, that's what I got.
Okay. Y-intercept is the easy one on this problem, which means X is 0. So Y is whatever, negative 5. Is that okay?
Yeah, let's think.
Okay. So the x-intercepts, which means y equals 0. So 0 equals 2x squared plus 8x minus 5. Let's see if I can use my calculator correctly this time. So I'm entering probably solve 2. -5. So I get x of 1, 0.549, x of 2, -4.549. That's interesting. Okay. So let's graph the sucker.
Oh, so that's what that means. Okay.
Hmm?
So should I just put it like that because I just rounded it up?
Well, it depends. Yeah, I mean, no, 0.5 and -4.5 is fine. That's fine. So my vertex is -2, -13. Okay. My y-intercept is -5. So it's gonna look something like this. Okay. This point is 0.5. This point is -4.5, roughly. And my axis of symmetry is x equals -2. Okay. The domain over here is -infinity to +infinity. The range is from -13 up, so bracket -13 to +infinity.
Yeah, I didn't get that far by myself, but yeah,
Oh, I'm sorry.
no, it's fine. Makes perfect sense. I mean, that part I know. I can't go below -13, so it has to be a bracket, and then
Right.
the range. I mean, is infinite, negative, and positive, right?
The domain.
Yeah, so it's just like all real numbers. The range.
Yeah, all real numbers. You could have said all real numbers. That would have been. You could have also said all real numbers.
Yeah.
That this is the -infinity to +infinity is just math symbols for these words. The words and the symbols mean the same.
Okay. Could we just try a inverse? An inverse. I don't know. Probably function.
Of a log or an exponent or just a regular simple line. We have 3 things we really emphasize. And that your question is good. Okay. The question is find the inverse function. But the problem is there was 3 types. We talked about linear, which would be something like f of x equals 3x plus 7. Or we talked about exponential, which would be something like f of x equals 2 to the x minus 5, or we talked about the logarithmic which would be something like f of x equals log base 2 of x plus 3. So we talked about inverse functions as just a general idea, but then we applied it to 3 different types of functions. So do you want to do all 3, or do you just want to wait a minute, or do you want me to walk you through it?
Yeah, can you give me a minute, please?
Sure, let's pause it and then we'll restart again. Real quick, I forgot to turn on the recording. You change f of x into y, you swap x and y, and then you try and solve for the new y value, get y alone, and then you write it as f inverse. I'm just reviewing because I forgot to turn it on. We started this problem, set f of x equal to y, swapped x and y, and then I indicated that there are 2 ways to do the problem from this point. One is the Bra-Bar rule, the other is take the log of both sides. Or he decided to take the log of both sides, the Bra-Bar rule. So if we apply that, that becomes the log base 2 of x equals y minus 5. Okay, add 5 to both sides to get y alone, log base 2 of x added with 5 equals y, which we write it as f inverse of x is log base 2 of x plus 5. And that would be the answer. Jorge, is that okay?
Yeah.
All right. Notice a really interesting thing here before I do the next problem. If we start with an exponential and try and find its inverse is going to be a logarithm. Okay, that's how you know you did something right. If you started with an exponential, its inverse should be a logarithm. So using that, if we start with a logarithm, its inverse should be an exponential. Okay, there's in my mind, in my eyes, there's a nice symmetry there. So here we go. So this is going to be y equals log base 2 of x plus 3. Swap it, x equals log base 2 of y plus 3. Okay, we have to use, in this case, there's no easy way. We have to use the Bra-Bar rule. So that would be 2 to the x equals y plus 3. Subtract the 3, so 2 to the x subtract 3 equals y, or we say f inverse of x is 2 to the x power subtract 3, and that would be the final answer. So again, if we start with a logarithmic function, its inverse will be an exponential. That's like an automatic.
Yeah.
Okay, we got about 2 more minutes. So, got a last second question.
No, I think that's it. I mean, it's just a little bit of a review, but
Yeah. Well, get out your exam 2, 3, and 4. Okay, and also print out that breakdown of topics and just sort of look at what's on the breakdown list, what's on exam 2, what's on the breakdown list, what's on exam 3. And you can find almost exactly what you need to study.
Okay.
Okay?
Yeah, I'll do that for sure.
All right. So I'll see you tomorrow night then. Okay?
Thank
All
you.
right. Awesome. Bye-bye.
Yeah, have a good night. Bye-bye.